So our speaker today is Carlos Vara Sánchez from the Complutense University of Madrid. He's a two-time Marie Sklodowska-Curie Research Fellow, previously at the University of Venice and is now at the Complutense University. And he recently joined the Millau team, which we are very happy about. He's conducting a project on reciprocal relations between actions, affective states, and intersubjective processes. Sorry, very interesting topic that I must say I'm not really very aware of. So it will be very interesting for me to hear his lecture today with a kind of a provocative or maybe everybody that is not into philosophy specifically topic, interdisciplinary research for philosophers and other non-scientists. So Carlos, the floor is yours to present us your thoughts about this very interesting topic.
Thank you very much, Liva. So yeah, this talk will be not exclusively or not mainly, let's say about my current project, but about the possibility of conducting interdisciplinary research from the field of philosophy and psychology, taking as a potential framework useful for this kind of interdisciplinary research, the so-called approach of 4E cognitive science. So the pattern, the structure of the talk that will follow is this one. I will start by introducing myself, at least my academic personal background, which is kind of heterogeneous, let's say. So after that, I will focus on the notion of interdisciplinarity, because it's connected with other aspects like multidisciplinarity, transdisciplinarity, and sometimes we use the term of interdisciplinarity as a synonym of other things, but there are relevant differences. Then I will go to the main part of this talk, which is the framework of cognitive science as an interdisciplinarity approach. I will start by presenting the classic notion of cognitive science as it was originated in the middle of the 20th century. And then I move to the 4E framework of cognitive science. I will go through the different E's, to the different 4 E's, to explain very briefly some ideas of what each of these is offered to the main framework for cognitive sciences. And then to finish, I will present some ideas also of the dynamic system theory, which is often used as a kind of common methodology to put together philosophical ideas, psychological research, neuroscientific data, work from linguistics, and all the different areas that constitute the cognitive sciences. So, who am I academically speaking? My degree is, I got one degree some years ago in biology in the University of Oviedo in Spain, but my interest was always focused on how we think, how we perceive the world, the different ways our brain and our body builds our experience of the world. So after finishing the degree in biology, I made a master's in neurosciences for 2 years in another Spanish university, Santiago de Compostela. And after this master, I got the opportunity to start a PhD in neurosciences, but I decided that this was not what I wanted to do, because I didn't want to do that kind of work, the kind of work in the laboratory that I was offered. So I decided to go to Barcelona and made another master, in this case in humanities, because I felt that my interest in studying how cognition, how thinking processes work was lacking, or philosophical roots, bigger, a broader point of view that it was not offered by neurosciences, but I thought that it could be offered by philosophy. So I moved to Barcelona and I made a master's thesis on the philosophy of this French philosopher who is in the picture, Jean-Luc Nancy. And after another 2 years in this master, I finally decided to do my PhD with the topic of this PhD research was the aesthetic experiences afforded by the video installations of Bill Viola, an American video artist, very famous. And in my mind, it kind of made sense because Bill Viola offers this kind of very long, very extended and complex experiences that combine visual, auditive, and also reflective experience. So I tried to put together very many different ideas from the 20th century philosophy about how we perceive time with some results in neuroscience. And this was the idea that I presented in my PhD thesis. However, after presenting the PhD thesis, I kind of arrived to a dead end in the sense that I didn't know what I wanted to do. So I spent 1.5 years thinking about working in other things and thinking about how to continue. And then I was very lucky to find a university, in this case, the Ca' Foscari University of Venice, which supported me for a Marie Curie proposal, a project which was called Enamare, an active model of aesthetic perception through rhythm and entrainment. This project allowed me to put together in a more thorough, in a more meaningful way, my double background as philosopher, biologist with an experience in neuroscience. So we decided to present this project to the Marie Curie call at the European Commission, and we were lucky enough to have the project funded. And so I spent 3 years in Venice working in this project. As I mentioned, it's called Enamare, which the main objective of this project was to study the functionality of the aesthetic component of general perception through the use of an enacted approach and conceptual tools from the dynamic system theory through the elaboration of an interdisciplinary framework based on the notions of rhythm and entrainment. During the 3 years that I spent working on this project, which started in May 2018, I have presented several papers, which some of them have been published in relevant journals such as Aesthetica or the Phenomenology and the Cognitive Science. And then I wrote a book, which will be published next month, the 14th of April, called Aesthetic Rhythms, which more or less presents the main ideas, the main conclusions that I reached during these 3 years in Venice. But after finishing this project in Venice, I look for different possibilities to continue broadening this scope, thinking of not only of the aesthetic component of experience, but this kind of interdisciplinary approaches to cognition, thinking of affectivity, intersubjectivity, and the material world, trying to put all these things together. Then I received a second Marie Curie, in this case, a co-founder Marie Curie to work at Madrid, at the Complutense University of Madrid, at the Department of Information Science. And this second project is called Affectance, which is an acronym for the name of the title of the project, taking care of affective affordances, dynamics, emergence, and intersubjectivity. This project started in last November, so I don't have yet any meaningful results. I'm just starting to put things together to write which will be the first paper of the project. But the main objective of this Affectance project is addressing the affective processes and the perception of possibilities of action, which is affordances, in intersubjective relations. The first 2 years will be focused on studying some of the different layers and processes potentially involved in the process, while the third and final year of affectance will apply the theoretical results to a specific phenomenon, which is social exclusion in schools, or what is also known as bullying. So, moving to the second point of this talk about interdisciplinarity, what do we talk when we talk about interdisciplinarity? Maybe some people think that interdisciplinarity or interdisciplinary research is like trying to put many different things together. Maybe other people think that, which is mostly the case sometimes, that interdisciplinary research is like trying to acquire knowledge from other fields and combine it with the one that you have from your field. But from my experience, interdisciplinary research mostly is sitting at a table with other people, talking, discussing, having what at the start could look like silly ideas, and they explore and go through them, and then arrive to some kind of theoretical or empirical compromise and develop a project together. Interdisciplinary research is something that is growing nowadays, but from my experience is the part that is always necessary for interdisciplinary research is talking, listening, thinking together. But as I mentioned at the start, when we talk about interdisciplinary research, there is all other times when we hear about multidisciplinary, transdisciplinary, intradisciplinary. So what do these different terms mean? Disciplinary research or intradisciplinary research, which are more or less synonyms, is the kind of research, classical research, that is carried out within one academic discipline, with one disciplinary goal setting that focuses on developing new disciplinary knowledge for this particular academic discipline. This is the form that the disciplinary that academic research has been having for several decades. You work within your discipline, you talk to your colleagues, and you keep focused on this particular objective. Then multidisciplinary research is when several or multiple disciplinary goal settings work under one thematic umbrella. For example, you can think of building a rocket for the NASA. You will have engineers, physicists, mathematicians, and people working together, each one of them in one particular field, but working together on one common idea. Then interdisciplinary research is the one that crosses several disciplinary boundaries and tries to develop an integrated knowledge. There could be thought that there is another step, which will be transdisciplinary research, which is something that it keeps being used more and more recently, but I would focus on interdisciplinary research. But transdisciplinary research will be this kind of research that has a common goal setting and is often considered to develop integrated knowledge both for science and society. One metaphor that I think that could be very useful to understand these differences between intra, multi, inter, and transdisciplinary research is to think of them in culinary terms. For example, interdisciplinary research will be that kind of research where we use a single ingredient. That ingredient remains clearly distinguishable. If we keep on advancing on the complexity of the research, multidisciplinary research will be like kind of a salad where the original ingredients are intact, but the flavors begin to blend. Interdisciplinary research will be more like a stew, where the original ingredients are still partly distinguishable, but the overall is a blended pot of mixed flavors. And finally, transdisciplinary research will be like making a cake, in the sense that you can no longer see the form of the ingredients as they have taken on a different shape and flavor. So, which will be some benefits and barriers towards this interdisciplinary research. This is mostly from my personal experience, but I've talked many times with colleagues in similar circumstances, so I think that could nicely apply to general interdisciplinary research in an academic environment. One benefit, obviously, will be that it broadens your toolbox, your conceptual toolbox and thinking processes. On the other hand, sometimes there is a lack of adequate measurements or recognition by disciplinary peers and institutional structures, because conducting interdisciplinary research, you will often, mostly always, you will find people who is much more familiar with particular notions of ideas. So you will be asked, why have you not presented something more in a particular topic? But interdisciplinarity in this sense can be sometimes tough to get this recognition when you present your projects or you present yourself for a position at different universities. Another benefit of interdisciplinary research is that it enables a comprehensive understanding of problems, issues, and research questions. However, sometimes it's difficult to find funding for this kind of cross-disciplinary exploration, because there is no always a clear goal just reachable in a short term. So there is a tension between these two aspects. Interdisciplinary research allows to tackle complex issues, but sometimes there are no institutional structures or research groups interdisciplinary enough to make possible the possibility to communicate and work together really in an interdisciplinary way, collaboration between the people from different origins. Interdisciplinary research allows us to create new knowledge, but at the same time, it questions established knowledge, which is sometimes not very easy. It can be a problem when, as I have mentioned, you try to get funding, you try to present some projects. So it's important to see these benefits and barriers like two aspects that are always go hand by hand, and you have to be able to benefit from the first and deal with the second. So why is inter and transdisciplinary research relevant? I have put here this long citation, but I think that it nicely encapsulates the importance of this kind of research. According to Cook, in a 2019 paper, he argues that solving many of the world's complex and pressing problems like climate change, sustainable agriculture, the burden of chronic disease, and aging populations demands thinking and working across long-standing, but in some ways restrictive academic boundaries. Academic institutions and key support structures, especially funding bodies, will play an important role in helping to realize what is really apparent to all who contributed to this paper, that interdisciplinarity is essential for solving complex problems. It is the new norm. Failure to empower and encourage those doing this research will serve as a great impediment to training, knowledge, and addressing societal issues. They presented this diagram, which shows that this approach to transdisciplinary research that combines the scientific approach, a more practical approach, and what is more or less in the middle will be more also philosophical social science approaches, where you analyze the problem, where you frame the problem, and explore its potential impact. These three aspects working together is typical of transdisciplinary research, but it could be also applicable to interdisciplinary research. But we should not think that interdisciplinary research is something new. According to researchers who work on the notion of interdisciplinarity, it could be, we can find examples of interdisciplinarity in many, many different places and times. For example, I just wanted to show this example that I think that is very interesting, which is the Mycenaean palace culture. So in this time, in the second and third millennium before Christ, in Crete, there was this society, the palace culture, which was a particular pattern of economic, social, and political organization that emerged in this Greek island in the Mediterranean Sea. According to Babbage, interdisciplinarity during the Mycenaean Greek civilization is reflected through many different factors: the growth of a political structure leading to economic trade and commerce, and the advancement of evidentiary writing and art to enhance and further a culture. What this combination presents is a level of learning not only about the Mycenaean culture, but where the Mycenaeans fit within the context of the world and their place in the world. However, nowadays, this notion of interdisciplinarity is not the one that we have in mind. We can think of interdisciplinary efforts like the one that we are working to evaluate and think and characterize different climate strategies to fight against this problem, but also another relevant interdisciplinary approach for some philosophers could be the way in which propositional logic is applied to think and build artificial intelligence. And also, for example, another field in philosophy, which is the one that I'm most familiar with, which is aesthetics, has collaborated with neuroscience, with computer sciences in different approaches to the aesthetic experience. And then we can find fields, relevant and new fields, such as neuroaesthetics, computational neuroscience, computational aesthetics. These would be relevant examples for philosophers, people working in humanities and social science, as a way to put together their theoretical research together with work conducted by people from neuroscience, from psychology, that could bring a more practical oriented approach. However, this talk will be more focused on the notion of cognitive science. So what is cognitive science? It could be defined as the interdisciplinary study of mind, brain, and behavior, embracing mainly, but not only, philosophy, psychology, artificial intelligence, neuroscience, linguistics, and anthropology. This triangle formed between mind, brain, and behavior, and the ways in which we approach the relation between these aspects could mean that we adopt different approaches to cognitive science, as we will see in the next minutes. One common image used to refer to cognitive science is this one, where we can see the main 6 disciplines that usually are thought or are considered to be part of cognitive science: linguistics, anthropology, neuroscience, artificial intelligence, psychology, and philosophy. But what is cognition? Cognition is a word that we often use, but it's not necessarily clear what do we mean with it. Cognition, it comes from the Latin cognitio, which in turn comes from the Greek gignosko. These are words that mostly talk about knowing. Cognition, about all, is about knowing. It's the process, the different ways in which we apprehend and elaborate information. So cognition is necessarily about the relationship between knower and unknown, that is, between subject and world. Cognition makes reference, as I have just said, to this triangle form between mind, brain, and behavior. Cognition is not only in the mind or in the brain or in the behavior. It's something that takes place or emerges, we could say, between these 3 realms of cognition. Originally, the discipline that was more focused on cognitive problems was philosophy, but then psychology, politics, economics, linguistics, sociology, and neuroscience, many different fields arrive and and started to work on different aspects of cognition and cognitive processes. So, as I just said, that this cognition could be thought as formed by this triangle between brain and the environmental and behavioral output, and this much more abstract idea or notion of the mind that, as we will see, is sometimes used by some researchers in cognitive science. Others don't like the idea of the mind and prefer to talk about the experience, but we can resort to the idea of mind today and it will be okay. Cognition has been often, but not necessarily shared this idea by all researchers, but cognition has been often considered to be like the middle part of a sequence between perception and action. We perceive the world, we carry out cognitive processes, and then we act upon the world back. This sequential notion of cognition has been called by Susan Hartley like the sandwich model of cognition, in the sense that we have two things at the sides, which will be perception and action, and in the middle, all the meat, which will be all the cognitive processes. So, traditional cognitive science has been based on what has been called the computational theory of mind. This idea arrived or emerged at the end of the 1950s with the so-called cognitive turn. There were many relevant researchers involved in this cognitive term, but I will just mention two of the most relevant ones. The first one, Noam Chomsky, with his work on the notion of universal grammar. He defended that all humans possess this universal grammar, which dictates what the space of possible language is. Chomsky collaborated a lot with another researchers, in this case a philosopher of mind, Jerry Fodor, and Jerry Fodor's main idea was that of the modularity of mind. What does this mean? That information is encapsulated and in different factions. That is, that you should be able to find in the mind and in the brain a particular region for thinking, another particular region for remembering, another particular region for imagining, and each one of these processes will be mostly isolated in these particular modules. So, if we put together Chomsky and Fodor's idea, we can see that the underlying metaphor under this nascent cognitive science is that the mind works as a computer. The work of the brain is to compute information. Cognition, according to this theory, emerges as a stepwise series of events that takes place in the agent's nervous system. So we should think, if we are following this approach, that the brain is the hardware, the thoughts, the software, the perceptual processes that arrive from the world to our brain will be the input, and our behavior, that is what goes from the body and the brain to the world, will be the outputs. This will be a very brief introduction to the computational theory of mind, which was adopted by traditional cognitive science when it was born at the end of the 50s, and for a long time has been the main, and maybe it continues to be the main idea between cognitive science, but as we will see, it could be the main, but it's not the only one. So what is important is that this computational theory of mind has influenced the way that research has been conducted. This ontological, this relevant, strong commitments to the idea of modularity of the mind, for example, have influenced how and what was being looking for when research on the brain was being carried out. So experiments to reveal the neural correlates of representational states of or the steps by which mental algorithms transform input into output. This was the more relevant focus of research, but researchers try to locate brain regions associated with processes and trying to integrate them in a linear model the same way that a computer works. Many cognitive science, as I have just said, continue to identify cognition with computation. For example, this quotation from the end of the last century is very radical about it when the philosopher mentions that we are mental self-models of information processing biosystems. If we are not computed, we do not exist. There are many theories regarding language acquisition, attention, problem solving, memory, or perception that follow this computational theory of mind. Most of the diagrams and results of these theories take more or less this form, this modular form in which we can see the arrival of the stimulus, different stages, different processes, which is something that someone who has been working on informatics and engineer which will be very familiar, because it's the same way that you model different computer processes. So, as I have just said, this traditional cognitive science approach is a theory. It's not necessarily true, but it's a theory. And thinking of the brain as a computer is just another step in the metaphor-laden conceptions of body, brain, and cognition that have arrived or have occurred across history. For example, the Greeks, which were very focused on research, for example, in hydraulics, they thought of the body like a water clock. For example, theories like Hippocrates' theory of humors can be seen as a correlate of this focus on hydraulic research. There are also many theories in the following centuries that consider the brain as a clock. More in the 18th and 19th century, we can find theories that thought of the brain as an automaton. At the end of the 19th century and the start of the 20th, we can find theories that think of brain and cognition like a camera. Now, I have just mentioned these ideas of the brain as a computer, and in the recent years, there are many theories that consider the brain as a kind of internet emergent pattern of processes. But this traditional approach to cognitive science has several issues. The proponents of these approaches defend that information is poor in the outside or in the environment and is enriched by the brain, which is something that is not shared with many researchers, as is very difficult to defend nowadays with some recent results. Also, traditional cognitive science defends that the body and the environment do not play a significant role in cognition. But is this true? There has been, for example, thought experiments considered by relevant philosophers such as Daniel Dennett, where they try to imagine how would it be to be a brain within a bat, something like a brain without a body, because this idea of a brain that works in isolation is what has been posed by many traditional cognitive scientists. And nowadays we know that the body, the organs within the body and the environment play a much more relevant role, and we have to account for this role of the body and the environment and their reciprocal influence between them and the brain, because otherwise we will be lacking a very relevant aspect of our reality. The problem with traditional cognitive science is that this emphasis in computers, in engineering, has or did leave behind relevant fields that originally made part of cognitive science, such as anthropology or even philosophy. But this started, there were also other issues. For example, at the 80s and the 90s of the last century, there were many research focused on brain imaging techniques to study the brain, but this was important and very relevant to obtain results about how the brain works, but to extrapolate the results from the brain to the mind is very risky, because there are many cases in which the papers and the researchers suggest that there exists a causation between a brain state and a mind experience, but we do not have proof about this being nothing more but a correlation. To understand the difference between correlation and causation, it is often used this kind of analogy that, for example, during summer, the hot of the summer causes us to eat ice cream and causes us to get sunburn, but there is just a correlation between eating ice cream and our skin getting dark, but no causal relation between these two aspects. So it's important always to keep in mind that correlation does not necessarily imply causation, which is something that many relevant research in traditional cognitive science has been accused to ignore. So this about classic cognitive science. Now let's move to 4E cognitive science. Cognitive science, 4E cognitive science was born as an alternative to traditional cognitive science. The theoretical roots of 4E cognitive science can be found in the philosophical field of phenomenology, also in the field of ecological psychology, and more generally in dissatisfaction against computational approaches that were getting more and more reductionist. So, in 4E cognitive science, the idea is that cognition has to be understood as the interplay of brain, body, and world. That is, we are not anymore thinking just of the brain as something that works in isolation, but always as a system formed by the brain, the body, and the world. When we speak of world, this word encompasses not only surfaces and objects, but also other people we engage with. Importantly, the claim that for cognition is that cognition, more than simply happening in some physical space, is something that takes part of a system that is constituted by transactions between organism and environment, and that enables and constrains experience in particular ways. In other words, we think, we feel, we imagine, we remember differently depending on our body and the world around ourselves. This will be the main idea about of 4E cognitive science. This idea of cognition as something that takes place between the brain, the body, and the world. But 4E cognitive science, what does this 4E mean? This term was coined by Sean Gallagher as a way to put together different approaches that were starting to move away from computational cognitive science, that were focused on different aspects of this interrelation between brain, body, and environment. 4E cognitive science means that cognition is embodied, embedded, enactive, and extended. Embodied means that the processes originated in the body play a role in cognition. I will, after introducing the 4Es, I will go through each one of them. So this was just to present a broad picture of 4E cognitive science. Embedded means that the processes originated in the environment play a role in cognition. Extended cognition means that objects and practices from the environment can substitute or enhance cognitive processes. And enactive means that processes taking part of cognition are not just passive. We play an active role in enacting, that is, in putting them into practice. So different researchers have focused on the role of the body, they will work on the embodied aspect of 4E cognitive science. Others have focused on the socio-material aspects of the environment, and they will work on embedded and extended approaches, and others will focus on the active part of cognition, and this will be like the area of inactive approaches to cognition. But watch out, different proponents of 4E cognition consider in different aspects, in different ways, their commitment to these claims, and consequently their interpretation will be different in which terms of mean to cognition to be embodied, embedded, extended, and inactive. Some people think that the body just shapes cognition, and others, for example, defend that the body plays a constitutive role in cognition. So we could speak of weak embodied approaches or strong embodied approaches. So we should think of this 4E cognitive science as a philosophical or conceptual or theoretical framework for research. So if we put together traditional cognitive science and 4E cognitive science, there are some very relevant differences that is very important to keep in mind these differences, because it will allow us to understand the transition from traditional cognitive science to 4E cognitive science. First, traditional cognitive science locates the mind in the brain and within the skull. On the other hand, 4E cognitive science is not that interested in the notion of mind. It's very often to find references to the notion of experience, but in any case, being mind and being experience is something that happens at the interaction between brain, world, and body. According to traditional cognitive science, our brains are isolated from the world. There is a gap between our brain and the rest of the world. But according to 4E cognitive science, we interact with the world. There is a metaphor that is often used that touching entails always being touched back. You cannot touch something, you cannot grab a bottle without you feeling how you are grabbing the bottle. So this will be something easily explainable or understandable under a 4E approach, but much more difficultly from a traditional cognitive science perspective. So another very relevant difference is that according to traditional cognitive science, cognitive processes are discrete and modular, but according to 4E cognitive science, cognitive processes are continuous, nested, and dynamic. This change from traditional to 4E cognitive science has allowed to reclaim the importance of fields such as anthropology or philosophy to the general field of cognitive science, has allowed to reframe interdisciplinarity and enhance these interdisciplinary approaches to different processes of cognition, and has granted a relevant role for particular philosophical fields and philosophy in general in cognitive science. So, moving on to the first embodiment. As I mentioned before, there are several competing theories of embodied cognition. There are those that defend a weak approach to embodied cognition, while others defend a stronger approach to embodied cognition, depending on the influential or constitutive role that they attribute to the body over cognition. However, I think that we will all agree that on the basic idea that the body plays a role. I think that it's very uncontroversial to acknowledge that the body shapes what we think, feel, perceive, and do. Depending on if we have a problem in one particular part of our body, it will shape our mood, it will affect what we want to do, it will affect what we can do. For example, if you have a broken bone in your foot, you will not be able to play with other people, so your mood will be different. So even if we agree on this, another important fact is that the body is and will remain a contested notion in terms of social order. there are many relevant questions about the body that cannot be easily answered. What is a body? What can you do with it? Who controls your body? What are you allowed to present or to defend with your body? So social aspects such as abortion, euthanasia, love, sex, mental health, incarceration, gender, soul, emotions, all of these controversial and very relevant notions for today's society are very influenced by the notion of body and the role of the body the role that we attribute to the body on our thinking and other cognitive processes. The philosophical roots of these embodied aspects of for cognition can be found in phenomenology. Phenomenology was a philosophical school that was born at the start of the 20th century. Two of the most relevant phenomenologists, the first one was Edmund Husserl, who coined the very notion of phenomenology. And for today's talk, what is relevant about Husserl's philosophy is the way in which he distinguished between two aspects of the body as a material body with physical properties, and the body from a first-person perspective as a perceived and felt body. He defended that there are these two dimensions of the body that cannot be reduced the one to the other. Sometimes we think of our own body as something material, but other times we think of our body as something that is experienced and lived from within. And these two aspects are very relevant and have to be accounted from different sides. The other relevant phenomenologist for the other very relevant phenomenologist for cognition is the French philosopher Maurice Merleau-Ponty. And he claimed that subject and body are inseparable. Here is Maurice Merleau-Ponty, and this very short citation. Merleau-Ponty argued that my existence of subjectivity is merely one with my existence as a body, and with the existence of the world, and because the subject that I am, when taken concretely, is inseparable from this body and this world. So in this idea of Maurice Merleau-Ponty, we can see that there is no way to separate brain and body. Brain and body are just one entity that is in which there is a reciprocal influence, the brain as part of the body as a container of the brain, but there is no way to trying to isolate the body from the brain. The role of the body in cognition, according to Merleau-Ponty, is neither a metaphor nor an abstraction. So how can the body affect the brain and the cognitive processes that we tend to think that take place originally only in the brain? First, the brain works through different waves and ways to coordinate in which we can register electric activity in different parts of the brain that takes form of so-called brain waves. But there are also many other different waves and rhythms in the body. We can register the rhythm of our heart, of our respiration, but also the rhythm of our gastric system, even the rhythm of the changes of electric conductance in the skin and other organs. There is an influence between these rhythms of the body and the rhythms that we register in the brain. And our movements, as this graphic shows, affect the activity in the brain. Something as simple as closing or opening our eyes instantly changes the pattern of activity in our brains. So, as many researchers have been studied in the last decades, we can consider, or we should consider, that brain and bodily oscillations are aligned to each other. Their frequencies do not vary randomly or arbitrarily. If a single frequency is known, whether it be from the body or the brain, all other frequencies are also known. This is what Wolfgang Klimesch defends in a very recent paper. Another take in this perspective of how the body shapes cognition has been offered by Asalini, Rebollo, and Talon-Baudry in an even more recent paper, where they claim that visceral signals are coupled with and sometimes drive spontaneous brain dynamics, indicating that the viscera and the brain form a single complex system. Here, what we can see in the image is the movement, the physical movement that every second makes the brain due to the impact of the heart activity. Every time that the heart pumps blood to the body, the brain moves and reacts to this movement from the heart and the blood. So we can think of this connection between heart, lungs, stomach, and brain as part of one of the ways in which the body shapes cognition. This leads us to the idea that the body is, in essence, an ensemble of fluctuating systems with biorhythms nested at multiple time scales. There are many researchers that have worked on this importance of the body upon brain rhythms. If you are interested, I can send you the references, but I just wanted to mention the work from Julian Mathera and Mara Thayer, or the work from Sarah Garfinkel and Critchley. For example, this last one from Sarah Garfinkel, they have shown that depending on the phase of our heart movements, depending on we are in systole or diastole, the ways in which we perceive the world change. We perceive fear better during systole and worse during diastole. So this has been connected, for example, that when you are in a situation of danger and your heart accelerates its rhythm and your systole are much more powerful, you will be better to perceive and to process phases of fear. But on the other hand, when you are more relaxed, you don't have to pay that attention to the environment. So you are left to think and wonder about your thoughts, and you are not paying that, you are not subject to this influence from the environment. And this is something that it constantly changes with each systole and diastole of our hearts. From a philosophical point of view, embodiment has been studied the way in which different affective states are interconnected. Moods, emotion, atmospheres, existential feelings cannot be isolated from intellectual cognitive processes. Embodied philosophy has been working a lot on the idea that thinking and feeling are just two sides of the same coin. We do not just feel and then think, or think without feeling. In every thought there is a feeling, and in every feeling there is a potential thought. This research has been, for example, some of the philosophers that have been working on this aspect of cognition has been Sean Gallagher, Thomas Fuchs, or Giovanna Colombetti. So moving to the second E, embedded, is very directly connected to the notion of embodiment. The philosophers that work on embedded aspects of cognition, which is also uncontroversial as I see, because we can all agree that what happens around ourselves, both in the short term, for example, the current situation, is there light, which is the temperature, which is the social context, are we in a pub, are we in a library, all these kind of things affect how we perceive the world, what we feel what we can do, etc. But also these aspects of embedded cognition affect us in the long term. The cultural background that we have, the social practices that we share, the geographical location in which we live, all these layers of the world constitute and shape our cognitive processes, shape what you perceive and how you perceive it. And this also provokes several related questions. What is the socio-cultural environment? To whom it belongs? How can we change it, etc.? And the relevant applications of embedded cognition can be related to identity issues, civil rights, ecological aspects, traditions, etc. So, if embodied cognition, the influence came mainly from phenomenologist tradition, in the case of embedded research, the main influence can be found in the American pragmatism, in the American school of pragmatism. There are many philosophers relevant in this school, but I will just focus on one of them, which is John Dewey. John Dewey has this very interesting and modern and even contemporary paragraph at the start of one of his main books, which is Art as Experience. This book, which was originally published in 1934, studies the relation between art and other aspects of experience for human beings. And at the start of the book, John Dewey argues that life goes on in an environment, not merely in it, but because of it, through interaction with it. No creature lives merely under its skin. Its subcutaneous organs are means of connection with what lies beyond its bodily frame, and to which, in order to live, it must adjust itself by accommodation and defense, but also by conquest. At every moment, the living creature is exposed to dangers from its surroundings, and at every moment, it must draw upon something in its surroundings to satisfy its needs. The career and destiny of a living being are bound up with its interchanges with its environment, not externally, but in the most intimate way. So here Dewey makes a very good point about this idea that we not live in an environment, but because of an environment. Depending on what we have around ourselves, we will be able to accommodate to the circumstances, we will have to fight the circumstances. There is an intimate connection between what we are and the world that surrounds us. It's something that cannot be only explained through the body and the brain, but to know what we are, what we can do, what are we going to do, we need to understand the environment that make part of us. Much more recently, there has been many relevant publications, several publications relevant about the importance of social aspects in embedded cognition. Just to mention one of them, Miguel Segundo-Ortin and Glenda Sadney last year published a paper in which they addressed the role of social and cultural norms in creating and shaping our interaction with the environment, the way in which social norms, even if they are not verbalized, they are manifested in the habits of perception action that predispose us to perceive and take advantage of certain possibilities of action instead of others. For example, if you are traveling to another country, there will be many different ways to do things when compared to the way these same things were done at your city, and it will take time for you to adapt, to know, to understand these differences. But until you do not adjust to these new social and cultural norms, there will be some aspects of connection between you and other people that will not be there. You have to be able to react, to adjust to the social and cultural norms, to become part of the social set of an environment of a particular place. In this case, one empirical example of the importance of the environment is the classical research conducted by Colvin Trevarten in the 70s and in the 80s. They made something that nowadays could see very trivial, but at the time was very edge technology. They put together, they connected a child and his mom, and they showed to the child a live video of his mother, in a way that the mother reacted to the movements of the child. So there was an interconnection, an exchange of gestures, of words between the baby and the mother. But after a few hours, the baby was shown just a recorded gestures and movements from the mother. And in this case, when the baby was just looking at something recorded, he immediately refused to interact. He shows distress, and there were relevant differences between looking at the live mother and the recorded mother. And even when the baby was only a few months old, he was able to react immediately to the difference between looking at his mom on a live recording or a recorded interaction. Moving to the third E, in this case, the extended cognition aspect of 4E cognitive approaches, is the extended mind. The extended mind was a very influential paper published by Andy Clark and David Chalmers in 1995. The paper, which is something that is very interesting to read this paper, not only you are into this kind of approaches, but just to read a very well-written paper, because just from the introduction, they started with this particular sentence: where does the mind stop and the rest of the world begin? It's like a kind of a novel in the sense that it gets your attention from the first sentence. And this is very important when you are writing a paper, I think, and they just were successful, extremely successful, because even if you agree or not agree with the claims that they make, one thing is clear, is that they just grab your attention from the very first word of their paper, The Extended Mind. But moving on to the theoretical claim that they made. They defended the very controversial idea that we are usually biased towards what happens inside our head, while we usually ignore the relevance of what happens outside our heads. And they defended that this bias that we present should be left behind, that we should think of cognition as something that takes place also outside our heads. Their main point is that if, as we confront some task, a part of the world functions as a process, which were it done in the head, we will have no hesitation in recognizing as part of the cognitive process, then that means that part of the world is, so we claim, part of the cognitive processes. And they finished the paper with this idea that cognitive processes ain't all in the head. So let me unpack this with one example that they use in the paper. They used several metaphors and analogies to explain this idea that cognition is not only in the head, but the most famous and probably the most relevant one is the story of Inga and Otto. So Inga and Otto, let's consider a woman named Inga who wants to go to the Museum of Modern Art in New York City. She consults her memory, recalls that the museum is on the 53rd Street, and off she goes. Now, think of Otto. Otto is an Alzheimer's patient. Otto carries a notebook with him everywhere, in which he writes down information that he thinks he'll need. His memory is quite bad now, so he uses the notebook constantly, looking at facts or jotting down new ones. One day, he, too, decides to go to the MoMA, and knowing that his notebook contains the address, he looks it up, this finds the direction, and off he goes too. So, the point that Chalmers, sorry about this, that Clark and Chalmers make is that before Inga consulted her memory or Otto his notebook, neither one of them had the address 53rd Street consciously in mind, but both would have said, if asked, that they knew where the museum was. The same way that if you ask someone if she knows the time, she will say yes, and then look at her watch. So what's the difference? Someone might say that whereas Inga always has access to her memory, Otto doesn't always have access to his notebook. He doesn't bring it to the shower and can't read it in the dark. But Inga doesn't always have access to her memory either. She doesn't when she's asleep or when she's drunk. So, according to the authors of the Extended Mind paper, the way that Otto uses the notebook is the same that Inga uses her memory. So this proves that the mind extends into the world and is regularly entangled with a whole range of devices. Clark and Chalmers and other proponents of the extended mind theory reject the idea that a person is incomplete in himself, shut in against the outside or in need of help. Human thought is so deeply different from that of other animals due to our heightened ability to incorporate props and tools into our thinking, to use them to think thoughts we could never have otherwise. So, a part of the world functions as a cognitive process, complements, substitute, potentiate what happens within our heads. When this paper was published in 1995, many people thought of it as something very strange, but I think that many of us now, with the relation that we have with our laptops, our cell phones, and many other things, we can easily and immediately understand that the notion defended by Clark and Chalmers in the extended mind was very, very ahead of his time, but very, very true. The notion of extended mind has been also applied to other things. For example, the research conducted by Lambros Malafouris in the material engagement theory, where he defends that the cognitive science, in a very interesting combination between cognitive science and archaeology, he defends that the tools that a civilization or a tribe has during some particular time of its history influences the processes, the mind processes, the thinking processes, and in this case, he focused on the relevance of pottery in the ancient Greek culture. And then moving on to the final E, an active approach. An act, as I said before, is to put something into action. And an active approach defends that most, if not all, cognitive, social, and affective processes entail a dynamic coordination between brain, body, and environment. This might seem counterintuitive, but according to some researchers on activism, experience is not something that happens to our brains, but instead is something we do, typically by moving our body around our physical and cultural environments. Brain as part of our body, experience as something that is not passive, but also active. There are several, as in the other cases, several relevant consequences for the active approach in philosophical, biological, and psychological research, with political, social, and anthropological consequences. The origin of the active aspect of recognition can be found in the book The Embodied Mind, published in 1991, which is very interesting because it had three authors: a biologist, Francisco Varela, a philosopher, Ivan Thompson, and a psychologist, Eleanor Ross, which is a very beautiful example of interdisciplinary research. According to the authors, the main goal of an activism is studying the dynamic relation between the biological living body and the experienced or phenomenological life body in relation to the environment. As we mentioned before, this was a very important topic for Marie Sklodowska-Curie, and is important in the embodied aspects of cognition, but the active approach takes this one step further and think of these two aspects together with the environment in a much more active way of considering cognition. There are many researchers conducting inactive research on different aspects of cognition. For example, Ridville and colleagues work on the ways in which skill and practices affect our interaction with the world. Di Paolo in the importance of language as an inactive action through processes of interaction, Sean Gallagher in social interaction, but there are many, many, many different approaches to aspects such as pain, memory, aesthetic experience, etc. The important aspect of the enactive approach is the idea that we do not just receive the world, but we enact it together, and therefore we have a responsibility in this enactment of the world. So putting all the is together, in classic cognitive science, we had the brain, but now in theory cognition, we have the body, we have the environment, we have the tools, and we have the active engagement with the world presented by the enactive aspect of theory cognition. But how can we put these aspects of cognition together? My answer is through dynamic system theory. This will be the final part of the talk. Despite relevant differences, for cognition intends to study cognition as a process that takes place at the dynamic intersection between brain, body, and environment. So, if the body, the sociocultural environment, the objects and tools shape or constitute cognition, and if we actively take part of our coordination with the world, we should think of all these processes as dynamic. This lead us to connect the theoretical research with empirical results through a connection, but not reducing the theoretical framework to data through a reductive processes. That is something that happened in many cases with classic cognitive science. But what is dynamic system theory? Dynamic system theory is a branch of mathematics that studies the continuous evolution over time of a system with a specific terminology and differential equations. Dynamic systems theory can be helpful to understand the way in which some behaviors emerge between different people. For example, the way that a group of people moves together during a concert. But it also be helpful to understand interrelations, not just only between people, but between people, tools, and the material world. And it also has been applied to study the evolution of behavior in the case of animals and plants. So the moment we apply dynamic system theory to the 4E approach to cognition, the picture gets bigger, it gets more broad, and we have to think and try to characterize individual, task, and environmental related aspects that, according to the dynamic system theory terminology, we should consider as constraints. So what is a constraint? They are not causes. They are just the conditions or factors that raise or lower barriers to energy, matter, and information. So for cognition, we'll have to detect and characterize different constraints in our interrelation with the world and in the interrelation between brain and body. But this notion of constraint can seem very abstract, but it's very intuitive. For example, the way you wear will constrain the movements and the way you behave. The place you are will also constrain your behavior. It's not the same finding a friend at a library that at a pub. At the library, you will make some side gestures, maybe you will text him, but if you find him at the pub, the behavior will be much more different. Another example of constraint is the mood you are. For example, if you are in a very bad mood, if you are feeling depressed, you will not like to do, or you will not be able to do some kind of activities. But if you are much more happy, the same activities will be more easily conducted, and you will accept to do some things that otherwise will not want to. So this things, the things that you put on, the place you are, and the mood you find yourself are constraints, because they do not case behavior, but they certainly shape and constrain behavior. So in cognitive sciences, the influence of moods over feelings, the sociocultural over behavior, the influence of slower bodily rhythms, for example, from the lungs or the heart over faster brain rhythms, or the influence of the affective over sensory motor can be thought of as constraints. So one relevant aspect of for recognition, one relevant aim for recognition is to identify, characterize, and connect, and if possible, measure and develop falsifiable models of specific processes, tasks, and situations through this notion of constraint. Theoretical and empirical fields of cognitive science this way could be allowed to work together in an interdisciplinary way. This notion of constraint is just one of the many different notions that are used in dynamical system theory, but this one in particular has been used to elaborate models for very different aspects of cognition. Here, this one was presented by Loaiza and Trasmundi, and they just elaborated a model of the ways in which psychotherapy works. They identified the different constraints and tried to put them together. There are many works that has studied the reciprocal constraining between brain, lungs, and heart activity. And this, just to conclude, lead us to the idea that there are different types of stability according to dynamic system theory between the brain, the body, and the environment. And we have to, it will be nice to try to understand these patterns of activity of cognitive processes, not just as the classic cognitive sciences do in terms of modules and individual aspects, but as an emergent patterns of stability. And this, for this reason, a growing body of research suggests that cognitive dynamics are better described in terms of mono, multi, and metastability. Life and cognition are inherently tensioned and often sustain states of criticality, where small perturbations can change the dynamics of the system. Cognitive science should study how bodily, brain, and environmental processes, tasks, events, and tools attract us toward these different types of stability. So hopefully, well, this was another example from Reed, but I think that is not necessary. So to conclude, I hope that this talk has helped to go from an idea that cognitive science at the start, when it emerged in the 1950s, it originally thought our relation with the world from a very individual modular perspective, but now in which the brain was something that it went from one process, from one module to another, but now instead we have a much more dynamic field in which there is place for empirical, very extremely scientific approaches, and others from humanities, philosophy, and others from social sciences to work together and map together the interrelations between embodied, extended, enactive, and embedded aspects of cognition. Thank you very much for your attention.
Thank you, Carlos. It was very interesting, I am sure, for all of us. Now let's give the floor for some comments or maybe questions. Does anyone have a question? Okay, maybe it was all clear. So nobody wants to ask. I have a lot of questions, but I'm not sure I can pose a question that would be like meaningful or something.
But cognitive science sometimes is not meaningful, so it's okay to make questions.
It's really hard, and yeah, it goes into how to say, into some philosophical depths that, you know, as you said, it's not that much within the body as. So yeah, it's really interesting, and gives a lot of aspects to think about.
Yeah, because I know that I have packed for sure too much information, but I just wanted to show like the big picture, because, you know, when I finished my PhD, I just felt like there was no place for someone with my background to make some contribution to the current situation in research. And my enter to this field of cognitive science was through an activism. I went to a conference on aesthetics, on classic philosophical aesthetics, and I found this researcher, Giovanna Colombetti, who has been working for several years in an activism. She was just mentioning some aspects of this kind of research, and for me, was absolutely a life-changing experience, in the sense that it allowed me to understand that there was a way to put together very different backgrounds. And it's something that you can resort to some research that has been already carried out, but there is also enough freedom to open your own field. For example, this research that I mentioned by Lambros Malafouris, the material engagement theory, it's a very, very interesting book, and the way that he puts together cognitive science and archaeology, and he arrives to these very powerful ideas about how the tools and the materials you work with can shape and affect the change of a society evolution and during time, across time. There are very interesting approaches to cognitive science in this 4E broader field that maybe were not possible in classic cognitive science due to their interest and their focus on engineering, informatic, and much more analytic approaches to philosophy.
Yeah, thank you.
There is a question I have read here in the chat about from Antonia Pavlova, that about recommending other books. I can recommend you many different books, but maybe it would be better if you write me an email to the mail address that is found in the screen, the Carvara. I just write it here just in case. And you can ask me about what is your more particular interested, and then I can suggest you some books on this issue. Because in case you are just interested in general cognitive science, I think that one very interesting book is the one of the embodied mind that I mentioned during the presentation, or maybe another more recent, which will be Enactivist Interventions by Sean Gallagher. But in any case, as I just said, maybe it's for you better to write me an email and just presenting which will be your interest, and I can give you much more personalized advice.
Okay, do we have other questions? Seems that nobody wants to ask. Okay. So maybe we should finish today's lecture. I will not pose my stupid questions. I will wait until we have some better opportunity. So thank you very much, Carlos, for
Thanks
this
for having me.
very interesting lecture. we will keep in touch and maybe organize some follow-up. Thank you very much also for coming, all of you. And if you have more questions or some comments, you can always send them to me or directly to Carlos.
Yep, please feel free to do it. Yeah. Thank you. Thank you very much to all of you for being here. Thank you.
Thank you.